Okay, welcome back to another video. This one's actually the first video in my second series, which won't be covering CSLA. I've been asked by many to do a basic C#, progressively getting harder in the video series, up to an advanced C# programming video class. So more than happy to oblige. It's good to go back to the basics at times, and so that's what we're going to do here. As always, you can get the source code at the URL shown. Just use the login and password CHI and CHI, and you can contact me at dean@advovet.com. Going to break this series into who knows how many videos. I don't even pretend to know. I'm going to try to keep them short, under 15 minutes each. We'll cover what little we can in that window. The first one, this video, is going to be the bare basics of C#. I'm not going to get into .NET, the framework, the intermediate language, none of that stuff. I'm going to assume that you as the viewer have a little bit of programming experience. You understand what a variable and a function is. At a basic level, we'll go over some of the things you can do with them, and that you understand that a console application runs with a program file and what a class file is. So with that, let's get started. I'm going to go ahead and minimize this out of the way. And I'm going to show you what we have for the project. The project's called Basic C#, which isn't a surprise. The two files that we're going to be interested in for this video are program.cs and simpletopics.cs. So the program.cs in a Windows console application, which is what this is, and we could add a Windows console application by going to our solution, going to File, New, and we could go Project, and it would bring up the project window. If it comes up in this window, we'll see. And we could just go in here and say we want a console application. We're not going to do it, but we could. That's how you add this project. And to add, as we know, items to a project, you simply highlight it, right click, you can go to add, and you can add a new item. They've got quick shortcuts to classes and things like that. But new item if you want to go through all your templates. But we've done it here for you, so we're going to get started and go down kind of what we're doing. In the program class, I'm going to pin it up here, Visual Studio 12. Basically what we do is we're only running through the main function. And what it's going to do, being a console application, it's going to execute this program from top to bottom. That's it. Nothing funny, nothing even too pretty, but really, really easy to see what's going on. Now the first thing you'll notice is these console.writeLine statements. All they do is in the black screen we're used to seeing when we go start run, is they put whatever text happens to be in here on the screen. So I'm really verbose into telling you what's going on, because it's important before we get into more advanced parts of C# to understand the order of execution as well as the syntax. You have to know what's going to happen when you put code out there. Otherwise you're going to be chasing the compiler around all day trying to figure out what's going on. So just understand it starts up here at the top, and these green are comments. You just use 2 slashes and you can put whatever you want in here, and it won't compile it, and so you don't have to worry about errors. This isn't C#, this is. Okay, so we're going to talk about objects. Now you say, well, that's not really a simple topic. Well, it is, because anything you do, you're going to do with object. Object-oriented programming is here, it's here to stay, and that's just how it is, so we got to get used to it. So we can see that we're creating some object of type simple topics called temp, and we're initializing it here. Well, let's take a look at this object and see what it is. There's several ways you can get there using Visual Studio 12. You can come over here and double click on it. Actually, in Visual Studio 12 you can single click on it and it'll take you to it, or you can right click on it and you can go to definition and it will take you to it. So let's take a look at what we've got here. My goal was to break this out into an object that we could look at as a basic class and what parts make up a basic class. First thing we got to understand is that a class is an active data structure that can store data and it can execute code. It contains data and code, and I say it up here in the comments. Understand your screen may look a little different than mine because I use a product called DevExpress. But you can do this same way with using 3 lines. Now, people have many definitions for what a class is, but that is a basic definition of what it is. It contains data and can execute code. Now, when you're declaring a class, all of this stuff we'll get to, but you have to say whether or not it's private, public, it can be sealed. There's a lot of things it can be. We're not going to worry about that in the intro class. But what you understand here is it's public, and that means that we can use it anywhere we want. So we go back to this program. They're in the same project, so even if it was not public, you could use it using some other modifiers, but we can create a type simple topics. There's where simple topics comes from. And the public is just the modifier, and we tell it, the compiler, that this is a class named simple topics. Now, if you'll notice, we go back to program, we said new simple topics. Well, when we tell it to do that, it goes out and looks for what's called a constructor. And on a class, you're always going to have a constructor, even if you don't put one in it. A constructor is nothing but a function with the same name and it's public, in this case, as the object. So they're easy to find. Now, I like to put my code into regions. And you just put a pound sign in the word region, and then down here you'll have a pound sign to end region. Here I put the constructors because you can have more than one. We're not going to get into that right now. Right now we have a default empty constructor we put in here. It doesn't take any parameters. And we just put console.writeLine simple topics constructor called. So all we're going to do is when you create that object, we expect it to put in the black screen simple topics constructor called. Okay, so let's see if it does that. I'm going to go over here back to program. It's going to do a whole bunch of other stuff, but what we're interested in, we expect to see starting program, and then we expect to see the next line is the constructors called. So what you do is you go to debug, start without debugging, and here's what it comes up with. This is a console, and it says we're starting the program, and then it says constructor called. That's exactly what we expected it to do. And then you'll see we do some other things with functions, and we'll get there in a minute. But I'm just going to hit any key, and this is going to go away. Okay, so the next thing that we do is if we look at this, there's only one constructor, so we know what this does. When you create the object, it calls the constructor, and it does what it says to do. Now remember, a class can actively store data, so how does it do that? Well, it does it in variables, in this case member variables. And I have done it one of many ways. Now what I like to do is I like to declare a private variable. In this case it's type integer, which is a number, and underscore number, and then you say this is the name of the variable, assign to it with the equal sign the value 1. Now, if we look here, we can see that the default modifier for this is private. And what that means is that if I go over here to program, and let's say I went here, and I went temp dot, there's no underscore number. You can't see it because it's private. Right? That's all that means, is that don't give people on the outside access. And so we haven't. Now, that begs the question, well, if it's private and someone wants to use the number out of this, how do we do that? Well, we create a public version of the number. In this case, it's number with a capital N, no underscore, and a capital N. Within this, we do a get and a set. You do not have to do both. Let's say you wanted to make number so that nobody could change it. You would simply not put the set in here. But since we do want people to be able to get and set it, we can include them both. We say, look, if they say number, give them whatever is in underscore number. So if number is 10, it'll return 10. And then if they say dot number equals 5, well, what do? Well, you set whatever value they send you into number. Now this obviously is not what you would put into production. You would not put this code into production. You would do a check to make sure that value is actually a number. Because imagine a scenario where they went in and sent some invalid value. What would you do? Perhaps you have a rule that says number can't be negative. So here in set is where you would do your rules check. You'd say, look, if value was less than 0, then you'd do something. Otherwise, assign the value to number. So you can understand how the set can get pretty complicated. Now the get is the same way. I mean, you could have rules here that says, look, if you're an administrator, say this was a social security number, if you're an administrator, you can see someone's social security number. But if you're a call center worker, you can't. And this is where CSLA shines, is that based on your role, you can make things public or not public. And it will simply just return the default value or nothing. But in this case, we're not doing any of that. We're doing very basic. But understand, I would never put this out there in production. I would do some kind of checks. The next thing we have is a string. Now, a string is just a sequence of letters, and it's surrounded by double quotes. This is the same, underscore name, and then we do the same public get and set. Now, the other thing we said we did is we could execute code. Well, the way you execute code is you create functions. These functions, just like the variables, have modifiers. They have a second part that says what they do. In this case, if you call this function, it doesn't send anything back. It simply executes some code, and when it's finished, it returns control back to whatever called it. So let me kind of show you what happens. We have a function called function that returns nothing but says something. And it takes your string, whatever I tell it, and it puts it on the screen. Nothing magic. Well, how does that work? Well, we declared the temp here. We call the function that returns nothing that says something, and we tell it what we want it to say. So what it's going to do is it's going to go in here into simple topics. It's going to run these 2 lines of code. It's going to find this bracket. And it's going to say, well, there's the end of that function. Go back to whoever called it. In this case, program.cs. And go to the next line. And we call another function, which is the value return function. Another type of function is a value returning function, meaning it does something, but it also sends something back to whoever called it. So what we would expect this to do is just like the code above it, whatever we send it, it's going to put on the screen, but it's going to send back to you a number. Now what number? That's up to you as the programmer, based on requirements and other things like that. In this case, just for fun, and to give you a little more advanced, we know that string is an object in the .NET class library. It can do many things, and so I just sent back input, and you do the dot, and Visual Studio is very good at helping you. It'll tell you everything you can do. In this case, I just sent back length. So it'll tell you how many characters are in the text you sent. How's that work? Let's go look. Remember, just like in a class, we have to tell it, here is a variable of type number, integer. That means it's not a .5, it's 1, 2, 3, 4, 5. We say give it a name, value returned, equals temp, function that returns value and says something, and I send him back my digit count. So what do you think is going to be in this value returned? Well, it's going to be the number of letters that are in this string. And then we put that on the screen. Now you'll see this, and some people get thrown off by this. All this says is put this on the screen, and when it sees these brackets and the 0, it says give me, instead of this, put whatever is the first thing after the comma. In this case, value returned from up here. So whatever we store here, we're going to put on the screen here. It's not magic. And then we're going to say, now let's do some math. And then we're going to say temp.add1 to number. Well, remember, in temp, in the simple topic, we have up here number, and in it is 1. So, well, what do you think is going to happen? Well, we're going to do a number plus plus. This is the same as saying that number plus plus is the same as saying this. Number assigned to number, the value of number plus 1. These two lines say the same thing. But in programming, as you get more advanced, you try to cut down on the amount of typing you have to do. So these two things are the same. It just says add 1 to number. Okay? And I shouldn't say add 1 to number. It says assign the value of adding 1 to number. So number will be changed after this. Because if I had just done this, number plus 1, that's valid. That's not valid, actually. If I had not told it to assign it to number, it wouldn't have worked. Okay, so I'm going to just remark this out, and we're going to do number plus plus. And then we put on the screen what number is. Now you say, well, why didn't I do this? I could have done this, right? I could have done that. Number plus plus, that's your private, certainly it's your private variable up here, but why wouldn't you do that? Well, you wouldn't do that because what if you have rules? Remember we said there could be rules that says if it's not a number, if you're not some role, if you're not, many things in a production environment that go into putting a value into this number, private number. So in this case, we use the public one so that we run our rule checks. And then we put under there what's there. And it's changed forever. It was 1, now it's 2. And that's what we say. We say, tell me what it was, do some math, put it on the screen. And then we go to modify name. Another value type is a string. Remember I talked about the string? And we have a string, it's called name. And what in it to begin with is Dean. And we have a public get and set. Well, let's think about what we're going to do before we look at it. If we're going to change a value of this name, are we going to use the uppercase or the lowercase? We're going to use the uppercase, right? And the reason we're going to do that is just in case there's some kind of rule check. It's just a practice I use, and most people use, especially those of us who do CSLA. You never use that, really, just because of rules. And so all we're going to do is we're going to say, look, we're calling this function. Here's what it is before we modify it. And then this is new. I could have just said name equals what it is plus the new value. But I want to get you into the best possible performance programming you can. And that's using something called a string builder, because what do we want to do here? Whatever you send to me, I want to add it to the end of this, right? So I could have done that like this. I could have said name equals name plus value. I could do that. And it would add whatever's in this value to the end of name. Because name, assign the value to name of name and that value. If I wanted to put whatever you sent first, I would do value plus name. But this is a less than desirable, although shorter to code, way of doing it, because the performance is not as fast as using something called a string builder. And what a string builder is it's an object, and it contains whatever you put in it. In this case, you use the keyword append, name. So the first thing I'm going to do is declare a class, just like this. It's got a constructor. It is a class, and its name. So we're saying, look, create a string builder class and name it SB. Inside that class, put the value of whatever is in name. And then inside that class named SB, add to the end of whatever stored in it, whatever value you sent me. Now, assign to name the value that is currently inside your string builder. This is faster to execute. And since I write a lot of server-side objects and high-speed objects, sometimes, and I'm contradicting myself pretty close to saying it, you need to go a little more longhand and get that little bit of extra performance. Because if you call this 1,000,000 times in a day, that's a lot of server time that you're saving. And then we say after the modification. And then this. Well, Dean, why are you doing this? Well, this is just something I like to do, is to go ahead and set it to null. There's something called a garbage collector in .NET that will go through and clean up objects and complex types so that you don't use all your memory. You could imagine calling this thing 1,000,000 times, and it takes a little bit of memory every time you run it. Eventually it's going to get slow, it's going to freeze up, and we're going to feel like we're running Windows 95 again. So the garbage collector goes through and cleans stuff up for you. But that makes programmers lazy sometimes. I like to set all of my objects that I use to null when I'm finished. Unless, in this case, it's at the end of the program. Because notice I never sent temp to null. Although I could have. I could have done this. I could have just went temp equals null. So we'll go ahead and do that. So we cleaned it up. So let's go through and run it. Well, let's go through and look, and we know this part works, right? And then what's the next thing we did? We said the simple topic function that returns nothing, and we say hi there. And then the next thing we did was what? We called the function that returned something and said hi there. And so, or not hi there, my apologies. We called a function that returns an integer, which is the count of whatever you sent it. In this case, you wanted me to write, I am sending back my digit count. And that is 33 characters. Where did that come from? It came from right here. I am sending back my digit count. I am sending back my digit count. And we assign that to this integer. And we write that to the screen. There's 33 characters. Now let's do some math. Now let's do some math, not magic. We're going to, inside the object, add 1 to number. Well, what was it when we created it? It was 1, right? So we expect it to be what? 2. And it says after adding 1 to the number, the value is 2. And then it goes on to tell us the new value of temp's number property is 2. And what that's saying is, look, we changed it to 2, and now it's forever 2 until we change it. Okay, the next thing we do is we're going to mess with some strings. Well, what are we doing? We're saying, look, the name value prior to the add is Dean. And what are we doing? We're adding to that was here. And then we say forever it's changed to Dean was here, unless we change it to it. Well, how does that work? This is something worth pointing out. I wanted to give you not everything boring and beginning. I wanted to show you how in the console.writeLine you can actually call a function. Remember I said when you hit this, it's going to go to the first value after the comma and put it here instead of that. So what we do here is we say, look, the value returned from modify name colon, get the first thing after the colon or the comma. Temp.modify name was here. And you say, whoa, how does that work? Well, it's going to go to the object and run the function modify name. We can right click it and go to the definition, modify name. It returns a string, so we can show that on the screen for sure. And it says we add it to whatever's in there. So, whatever this function here returns, it's going to put here. The compiler's smart enough to figure that out for us. And let's see that one more time just to prove to you. And I hit the wrong one, of course. Yeah, I know you can't do it. Name value prior to adds Dean, which we knew. and name value after modifications, Dean was here. Pretty simple stuff. So that concludes the first video. I know it's, for some of you, it's like, oh my gosh, that was simple. But for others who are just getting into it, I hope that it was a good basis. I mean, there's many, many tutorials out there. Many, many, many good books. I tend to favor Murox and Apress. For beginning people, the Murox series are excellent. C# 2012 is a great book. And then there's another one. It is, and I shouldn't say Murox 2012 because it's not out yet. Murox 2010's out. 2012 will be coming. There's another one called Illustrated C#, 2012 by Apress, and it's really good. You can grab those off Amazon or Nerd Books, NERDBOOKS. It's sometimes a good place to get one.com. So check them out. Give them a read. They're worth it. I'll continue making these little videos. They're not going to cover everything by far. I simply don't have that much time. But I'll cover some high points, give you some little pointers as we go through it. And what you'll notice on the solution, if we look at it, the intermediate topics class I'll fill in, and the advanced topics has its own folder because we're going to do some object inheritance, some threading, and things like that. So I hope you enjoy the video, and have a great evening.